Hey guys, sorry about the technical difficulty. So again, as I was just saying, make sure that you end up in descending exponent order, right, when you get your final answer. All right, so let's take a look at our first example here, example A, which is the binomial of x plus 5 times the trinomial of x squared minus 3x minus 2. So the first thing we're going to do is we're going to take the first term of the binomial, so this x right here, and we're going to multiply each term of my trinomial, so the x squared, the negative 3x, and the negative 2. And I'm going to multiply them each individually. So x times x squared. Now remember, they have coefficients of 1, and 1 times 1 is 1, so we don't necessarily need to do anything there. And then x times x squared, remember that is the product of powers rule. So we are going to add exponents. This one has an exponent of 1, so when we add them, we end up with x to the third. Then we're going to do the second term of the trinomial. So x times negative 3x. Well, 1 times negative 3 is negative 3. And then x times x, well, the exponent of 1 and 1 makes 2, so x squared. Then we're going to do the third term. So x times negative 2. Well, x times negative 2 is just negative 2x. So now we're done with the first term of the binomial. So now we're going to go back and do the second term of the binomial times each term individually. So that is the positive 5 here. So we're going to take that positive 5 and we're going to distribute it to every term in our trinomial. So positive 5 times x squared. Now again, if the binomial and the trinomial are in the descending exponent order, I can use that stacking method really easily by sliding 1 to the right, which they are. So positive 5 times x squared. 5 times 1 is 5, so positive 5. No x's to combine with, so keep that as x squared. And as we see, that lined up my like terms. Then I'm going to do it again. Positive 5 times negative 3x. Well, positive 5 times negative 3 is negative 15. The x here has nothing to multiply with, so bring it down as well. And then my last term, so positive 5 times negative 2. Well, positive 5 times negative 2 is negative 10. So now I've distributed every term from the binomial to every term of the trinomial. So now I should be able to combine like terms and make sure it's in descending exponent order. Well, nothing to combine my x to the third with, so I'm going to bring that down. Negative 3x squared and positive 5x squared is positive 2x squared. Negative 2x and negative 15x is negative 17x. And then negative 10, nothing to combine that with, so bring that down as well. So again, if my binomial and my trinomial were both in descending exponent order, that means that this should be as well, but let's just check. My biggest exponent is 3, the next biggest is 2, the next is the 1, and my constant is at the end, so that is in descending exponent order and would be my final answer. All right, well, let's take a look at example B using that exact same method. So again, the first thing we want to do is take the first term of the binomial, so this x right here, and we want to distribute it to every term of the trinomial. So x times x squared. Now remember, they both have coefficients of 1. This x has an exponent of 1. So 1 times 1 is 1, and x to the first times x squared is x to the third. Then the second term, so x times negative 4x. Well, 1 times negative 4 is negative 4, and x times x, add the exponents, so 1 plus 1 is 2, so x squared. Then the third term, so x times negative 4. Well, 1 times negative 4 is negative 4. This is the only x involved, so I'm going to combine or add that on there, and that is the first part of the multiplication. Now, again, if this binomial is in descending exponent order, which it is, and this trinomial is in descending exponent order, which it is, then I can slide 1 to the right in my stacking method, and all like terms should line up. So that means I've got to take the second term of the binomial, so that's the 3 plus the negative sign in front of it, so negative 3, and multiply each one of those, or that times each one of the trinomial terms individually. So negative 3 times x squared. Well, negative 3 times positive 1 is negative 3. These are the only x's involved, so I'm going to bring those down, so that makes it x squared. Again, as we see, these are like terms. They both have x's to the second power. So then I do the next one. So negative 3 times negative 4x. Well, negative 3 times negative 4 is positive 12. The x is the only one involved, so bring it down. So again, x, and these are like terms as well. And then my last one, negative 3 times negative 4. Well, negative 3 times negative 4 is positive 12. So we are done with the multiplication. So now we can combine our like terms by going down the columns. So x to the third, nothing to combine with, so bring it down. Negative 4x squared and negative 3x squared. Well, negative 4 minus 3 is negative 7, and they are x squared type of terms. Negative 4 times positive 12, well, that is positive 8, and then they are x types of terms. And then positive 12, nothing to combine that with, so bring it down as it is. So again, because both of these were in descending exponent order, that means these should be as well, but let's check. Power of 3, power of 2, power of 1, constant, so that is our final answer. All right, well, let me move this up so we can see examples C and examples D. I'd encourage you to try example C on your own, then check your answer with mine. So again, first thing we do is take the first term of the binomial, our x here, and distribute it to every term in the trinomial. So x times x squared. Again, remembering both of them have coefficients of 1, and 1 times 1 is 1. The exponent on this x is 1, and x to the first times x squared, we add the exponents, so that becomes x to the 1 plus 2 is 3. So that's that, again, that product of power rule. Then we do the second term, so x times positive 5x. So 1 times 5 is positive 5. And x times x, again, this has an exponent of 1, so we add the exponents. So x to the 1 plus 1 is 2, so 5x squared. Then we do the third term, so x times positive 8. Well, x times positive 8 is positive 8x. So we are done with the first term of the binomial. Now, again, because this binomial is in descending exponent order and this trinomial is in descending exponent order, I can go into my stacking method. So when I multiply my second term of my binomial and everything, I'm going to slide 1 to the right, and that should line everything up in terms of like terms. So 1 times x squared is 1 times 1 is 1. And x squared is the only term, so I've got positive 1x squared, or I could just put x squared. Either way is fine. Then I've got positive 1 times positive 5x. Well, 1 times 5 is positive 5. This is my only x involved, so I'm going to bring that down. Again, my like terms are lining up as they should. And then positive 1 times positive 8, that is positive 8. So now I've done all my multiplication, so now we should be combining like terms. Because the binomial and trinomial are in descending exponent order, the like terms lined up easily, which means my answer should be in descending exponent order as well. So we go down the columns, x to the third, nothing to combine that with, so bring that down. Positive 5x squared plus 1x squared. 5 plus 1 is 6, so positive 6, and they are x squared kind of terms. Positive 8x and positive 5x, well, 8 plus 5 is positive 13, and they are, again, x types of terms. And then the positive 8, nothing to combine it with, so bring it down as well. And then, is it in descending exponent order? Well, 3, 2, 1, constant at the end, so yes, it is. All right, well, I'd encourage you to try example D on your own, then check your answer with mine. So example D, again, beginning with the first term of the binomial, we're going to multiply n times n squared. remembering that those have coefficients of 1. So 1 times 1 is 1, so no change there. N times n squared, we would add the exponents, and this has an exponent of 1. So that is n to the 1 plus 2 is 3, so n to the third power. Then n times negative 2n, I'm sorry, my pencil keeps breaking. Well, that again has a coefficient of 1, and 1 times negative 2 is negative 2. N times n, again, remembering that these are exponents of 1, and 1 plus 1 is 2, so n squared. And then n times positive 4 is just positive 4n. So now I've done the first term of the binomial, so now I need to move on to the second. Again, if both of these are in descending exponent order, which they are, that means I only got to slide 1 to the right in my stacking method, and all like terms should line up. So negative 3 times n squared. Well, negative 3 times n squared is just negative 3n squared, because negative 3 times 1 is negative 3, and n squared are the only n's, so bring them down. Again, like terms are lining up. Then I've got negative 3 times negative 2n. Well, negative 3 times negative 2 is positive 6. Again, this n is the only one involved, so bring it down. And then last one, negative 3 times positive 4. Well, negative 3 times positive 4 is negative 12. Now again, I'm done with the multiplication, so now I need to combine my stacks. So n to the third, nothing to combine it with, so bring it down as is. Negative 2n squared and negative 3n squared. Negative 2 minus 3 is negative 5, because those are all bad guys, and they are n squared type of bad guys. Positive 4n and positive 6n. 4 plus 6 is positive 10. And they again are n type of terms. And then negative 12, nothing to combine that with as well. So that comes down as it is. Now again, it should be in descending exponent order, but let's check. 3, 2, 1, constant at the end. So that is my final answer. All right, well again, just don't forget about that product of powers rule that says if you have the same base multiplying itself, so essentially the same variable, we add the exponents together. All right. Otherwise, you should have what you need to begin the worksheet for this assignment.